Dear students, so today I will be teaching you a library of Python that is called NumPy. So NumPy is a very interesting library, and in this library, you can have some multiple functions which is related to arithmetic function, the arrays, and the multidimensional arrays as well. So you can have indexing and slicing. You can have arithmetic and statistical function as well. So there are a lot of libraries in Python. The one is NumPy, which you might have used in your practices. Matplotlib, it is for plotting plotting some graphs. Pandas, we have it. We have a scikit-learn. We have a TensorFlow for deep learning. We have a SciPy. We have a Keras is also for the deep learning. So these are multiple libraries we have in a Python. So today we will talk about NumPy, that how NumPy works. So yeah, so NumPy, they have a lot of function as well, some built-in functions which we will discuss in detail. So how we can import the libraries, this is called import NumPy as NP. So you can import the library as follows. And these are different examples. We will do this one by one in Python and we'll see how it works. So these are the different functions we have. We can apply some arithmetic operations. We can have statistical operation. We can have bitwise operation, means adding 0, 0, 1 and multiplying 0, 1. Exclusive OR operation, copying and viewing operation, stacking operation. You can have matrix operation, means like SFOOF, and you can have linear algebra, broadcasting, mathematical operations, searching and sorting, and counting. Right? So we have built in a lot of functions in this one. So I will go one by one through that one. So let's go to the um, Python library. So how we import it? So import NumPy as NP. So this is that how we import the libraries, right? So in case if you want to define what you call it, we want to define some one-dimensional array. So how we can do it? So there are certain examples. I just performed that one. For example, this is a one-dimensional array. I just for saving the time, I just copy for you here how we do it. So for example, this is one-dimensional array. So the one-dimensional array means like, for example, you can name anything. For example, one dimension. For example, this is one of the dimensional array, one dim, right? So you can give any name, and right then you have to write like, for example, equal sign. Then you need to assign the values to that one. So this is any variable. So you say numpy dim1, let's suppose, okay, and then say np. So np, we have given the alias name. So this is the alias name. Alias means like a nickname for an NumPy, right? So this is the NP over here. So because we can write NumPy as well, but this will be longer. So in short, we write NP, right? And then we say array. So what kind of array we need? We need a one-dimensional array. So this is a one-dimensional array. So if I just run this one, this will be run. But if I want to print this array, so I need to like one underscore dim1, right? So by this way, this will be this will be printed for you. Now let's see some other functions. Okay, now with this array, we can have some more functions like ndim. So ndim, there is a function with ndim, so we'll see that how it works and where it can be used over here. So let's see over here. Let me have this removed one and this function. Okay, okay. So if I go for this one, yeah, so the dim function can be easily done. Okay, for example, if I want to have this one print, okay, one underscore dim1 dot ndim. So ndim, we will see what is the function of this one ndim. So ndim means like what, how many dimension it has. So it's a one dimension over here. If it is two-dimensional array, so the results would be different over there. For example, then let's suppose this is a two-dimensional array. So dimensional means like in how many rows and columns it has. So it has only one row. Okay, so when you have one row, that's called one dimensional. So in this case, what we have it, this is very simple here. So then we have one dim, and then let's suppose if we want to have some shape, and how the shape will look like. One dim one dot shape. Okay, the shape will be like, yeah, so the shape is 10, so it means that how many, like, the 10 digits are there from 1 to 10, right? Okay, then we have some other characteristics. Let's see, if you look at your lab, so we will have some other characteristics. Then size. Okay, so let's see the size of that one. Okay, let me just copy just for save the time. We have, like, shape, and then we have a size for this one. It will be, yeah, the size is also 10, right? And then we look for the D type. So D type means what is the data type of that one. So we say D type, and the D type is, yeah, integer type, right? So if the value is floating, let's suppose if I change the value here, if I make it like, 1.1, okay, so it will be the floating value. So the data type will change to from integer to float. See, now the value has been changed to the float value from the integer. Okay, now let's suppose I want to have a two-dimensional array. So how we can have two-dimensional array? So from the two-dimensional array, so it's like, easy, but you have a different structure over here. Now let's go to the next slide, and if you just want to apply the two-dimensional array, so here you can see you need square brackets, okay, for the rows. So how many rows it has? 1, 2, 3, 4, and 5 rows over here. And how many columns? 2 columns, right? So let's have the same, for example, the same example, but here we will have another two-dimensional TWO2 dimensional. Okay, and here we will, like, change it to brackets. Okay, and then here another brackets. Okay, and here another bracket, here another bracket, another bracket, right? Okay, here another bracket, right? So and we have a collective bracket as well, like from end to end brackets as well, to have this two-dimensional bracket up. So it works well, right? Now I need to print it, this two-dimensional array. So how it will be showing us? Okay, okay, so it will be, yeah, so now you see it's different. So before it was one row, but now it is like, it's a multi-dimensional array. So now you can see how many rows we have here. 1, 2, 3, 4, 5, 5 rows we have it, and 2 columns, right? So this is, and similar function you can have it with it. Like, um, uh, for example, now if I run this command, this one, ndim, so the ndim would be different, but here the array name is two-dimensional one array, and now it's two-dimensional. See, and is two-dimensional. So if you make it three-dimensional, so it will be then three-dimensional. If I increase one more element, so it will be like, more elements will be over here. For example, I'm increasing the number of elements over here. It will be, now the number has been increased. Now you can see the update over here, right? Okay, so since still it is a two-dimensional because it's not a three-dimensional, so the end name will be the same. Let's see the shape. So shape will be like okay, let me have copy this one. Okay, the shape is like, shape, shape. So shape of this array, which is like 5 and 3, so it means 5 rows and 3 columns, right? Okay, now let's see what other functions we have. It size. Okay, let's see the size. Okay, so the size would be 15, right? So the total elements, 5 multiplied by 3 is 15, right? Okay, so total elements are 15. That's why the size is this one. Let's see the type. D type means like what is the data type of this one. So it would be integer, right? So if I make any one element as a point, so it will be a floating then. So let's see. So now the points are changing. So it will be from integer, it will change to floating. Okay. So so this is like, practice. So now let's see some other examples from that one we have seen. Okay, now we have some other like built-in functions like a uniform. We have it. I apply the uniform function, so how it will work. So let's see with, but it works with a random number. So it will select random numbers from the uniform, okay, and it will have a uniform distribution for 0 location, and 1 is scale, and 5 is the size, right? So if I change the size, it will be changing the size. Let's suppose if I have this array, so if I make it 6, so it will be the size will be changing. It's changing over here. If I make it like 10, the size would be changing for this uniform distribution, okay. And similarly, if I do this one, so there will be a different change as well. If I make it 3, so the scaling would be changing, right? Scale is will be changing over here. And then we have like um, normal distribution. So the normal distribution also here, we see over here. So this is the location, this is the scale, and this is the size. So here also, if I make it 5, so the size would be changing over here. If I make it 1, so what will be the change? You see over here, the change. This is the change over here. If I make like a 5, so the distribution would be change with over here. So let it be 2. So what is the change in effect? So you see over here, there is a change of 0.5. Okay, now arrange, if you want to some arrangement of this one, of this any array. So if you look over here, if I want to arrange these numbers, let's suppose this is an example over here, this is a new example. So in this one, what we have it, like I want to arrange from -5 to +5, so it will be, let's suppose, let me change it to -10 to +10. Okay, now see what is the result of here. Now see from -10 to +10. So +10 is not included because we have 0 in between that one. Now here, this is another example arranging. For example, I need to arrange 12 numbers from 0 to 12, or if I just make change it from till 15. So let's see how it works. Okay, so there is an error, right? So why this error comes, I will tell you why this error comes. So this is okay now. So it means that if I want to arrange it, so it should be 6 multiplied by 2 is 12, right? So it should be like, the multiplication should be okay. So if I 4 multiplied by 3 is 12, so it will work, right? So now see this size is changed. So I need, for example, if it is 12 multiplied by 1, it must be working as well, right? See, now it is working. So there should be the reshaping. If you want to reshape the array, so you need to, like, it should be the multiple of that one. And then we have, like, line space. A line space is like, how it works. So here, for example, if you start from 0, if I make it 5, so let's see how it works. So this the result would be changing. So you can see the effect of that one. With the 10, the result is like this one. Okay, and if I make it 10 this one as well, so the result would be more different over here. And then we have a log space. So log space is also working. If you just, like, make changes, instead of 3 2, you make it 3, so you will see the effect of the log space as well. Yeah, now it's changing. Okay, the other interesting function is the zeros. If you want to create a array of zeros, so for example, if I want all zeros in this array, so this will be like this. So for example, if I want to make it 5 and this make it 7, so the array size will be changed bigger. Now if I want identity matrix, all on the diagonal is 1. So for example, if I want another matrix, it would be 7, it's bigger. Yeah, now it's 7. If I want to make it 10, it will be more 10. Okay. And similarly with this one and this one, so if I make it 10 as well, so look at this one. Do I create the similar matrix or different? Yeah, similar matrix, right? So it means that it works. So these are the different functions in a NumPy library. So you must need to import this library. If you don't import it, so it will not work, right? So this is very important to import it, right? Okay, now let's try, for example, if I just want to make this one one dimensional underscore uh, dimensional, make it like, for example, another array, uh, 3, let's suppose. Okay, and I have this one. Instead of NumPy, I just write NumPy, okay, dot array. Okay, and if I make it like this one, 3 comma 4, 5 and then run it. So let's see whether it works or no. Okay, so there